1.1 absolute value functions. This is our exploration that goes along with your student journal. The essential question that we're going to be answering is how do the values of a, h, and k affect the graph of the absolute value function? We have a, h, and k, and we want to know what they do to the graph. So we're going to be comparing all 6 of these graphs, and so you want to look at how they're alike and how they're different. And one of the things you should notice when you're looking at them is that graph B, D, and E all seem to open down. That means they've been reflected over the x-axis. Remember that reflection over the x-axis happens when A is negative. Well, we've got A to be negative here in A. Here in C, we have A to be negative. And then also here in F, we have A to be negative. So those 3 are going to fit with B, D, and E, which means that B, D, and E over here on your equations are going to go with A, C, and F. Another thing I notice when I'm looking at all the graphs is most of them seem to be the same shape. They're certainly all the V for the absolute value graph. I'm talking about how open it is. Is it open wide? Is it open narrow? Has there been a stretch or a shrink? And the only one that appears to have a stretch or a shrink is here in A. It seems to have a vertical stretch. Well, if I look at my equations, I know that for a vertical stretch, A has to be greater than 1. And so if I look at my equations, I find that E has an A value greater than 1. It also has a -2 for H. And remember that H, if that's a -2, that means H is +2. So it's going to move to the right 2. And this graph did move to the right 2. So A matches with E. Or I could say graph A goes with E. Then I'm going to look at some of the others. If I look at A is one that's been reflected over the x-axis. And again, H is a +2, which means it's going to have moved to the right 2. So I'm looking for something that's flipped over the x-axis and moved to the right 2. This one B has been flipped, but it's not moved to the right. D has been flipped and it's moved to the right 2. So D goes with equation A. For B, H is again +2, so this one's moved to the right 2, but it's also moved up 2 because K is a +2, and we know that K shifts our graph up and down. So for this one, since it hasn't been reflected, it should open up. We know it moves to the right, and we know it moves up. So if I look at C is opening up, it moves to the right 2 and up 2. So C matches with equation B. Equation C is one of our ones that's been reflected. Here we see a +2. That means H is actually a -2. Remember, because the equation has the -H. So this one is going to move to the left 2. And since K is also a -2, it's going to move down 2. So we're looking for one that's been reflected and then moved left and moved down. That looks like E right here. Over 2, down 2 to get to the vertex. And it's been reflected. So E goes with equation C. For D, H is a +2, so we're going to move to the right 2. K is a -2, so we're going to move down 2. And it hasn't been reflected out here because we can see A is positive. So if we look at our graphs, F is opened up. We go right 2 and down 2. It must be F. D matches with F. And then our last one should obviously match with B, but let's just double check it. It should be a reflection over the X, which it is. H is -2, so it's going to move left 2. K is +2, so it's going to move up 2. Left 2, up 2. All right, that one is F. So the question was, how do the values of A, H, and K affect the graph of the absolute value function? So A tells us whether or not there's a vertical, shrink, or stretch. It also tells us if it's been reflected over the x-axis. And what does h do? H moves it right or left. And k moves our graph up or down. Number 3 says to write the equation of the absolute value function whose graph is shown. Use a graphing calculator to verify your equation. So we know the basic, is f of x equal to a x minus h plus k. We need to fill in our values for a, h, and k. Now sometimes those values are going to be 0, and that would be fine too, and we'll just look. For this one, we see that our graph has been reflected because it opens down, so that tells us that a is going to be negative. So f of x equals negative. It doesn't appear to have changed shape. If I go over 1 and down 1, that tells me we're still in the basic shape. So -1, or just negative, the absolute value of x minus, and it looks like this one has moved to the left 1. Since it's moved to the left 1, let's erase that. Since it's moved to the left 1, that means h must be -1, and it's moved up 1, so k must be +1. Well, x minus a -1, we know is going to be x plus 1, and then k is +1, so +1. And there's our equation for the graph.